Historically, AI has been an observer. You invite a bot to a call, it sits quietly, listens, and spits out a summary an hour later. It merely acts as a digital scribe. The traditional approach on the left transcribes speech and extracts action items, but OpenClaw integrates directly into Google Meet as a live participant. Look at the right side, agency. A recorder documents, an agent listens, reasons, responds, and triggers new software workflows in real time. We can see how this reorganizes the interface itself. Google Meet is pulled down into the OpenClaw agent workspace. The video app becomes a direct input, a controllable surface, wired right into the AI's core toolkit alongside your calendar, documents, and task manager. The assistant is moving out of the isolated chat window. It is stepping directly into live human collaboration, taking audio from meetings and turning it into active, continuous work loops. Hey, don't forget to subscribe if you find any value here and leave your feedback down below. Let's get back to it. Getting a software system to seamlessly attend and process a live human conversation requires an entirely new underlying architecture. This diagram breaks down two critical layers. On the left, the meeting join infrastructure uses Google authentication, explicit URLs, and Twilio transports to establish a presence. On the right, the artifact layer parses unstructured dialogue into retrievable files, compiling transcripts, smart notes, and attendance records. Those artifacts then feed into the central OpenClaw agent runtime, seen here in the middle. Because the meeting data is now structured, the orchestrator can immediately pipe those insights outward to automate a browser session, create a calendar event, or update a CRN document. By structuring the audio in real time, OpenClaw turns a 45-minute video call into a retrievable data stream that feeds directly into the agent's memory. Voice AI faces a strict technical trade-off. If a model generates speech fast enough to feel like a natural conversation, it rarely has the computing time required to execute complex reasoning or search for external data. OpenClaw uses this two-part system. The top real-time voice loop handles fast, low-latency conversations, but for complex queries, follow the on-demand consult arrow. The voice model triggers an OpenClaw agent consult, passing the query down to the full OpenClaw agent to retrieve a tool backed answer. This mirrors how a human assistant works. They answer basic questions on the spot, but ask for a moment to check their files when the problem requires deep research. Sustaining this multi-step architecture creates an immediate economic problem. Processing an hour of live, continuous audio alongside complex background reasoning generates massive amounts of expensive computational tokens. To solve this, OpenClaw integrated DeepSeek V4 as its default model. The center outlines its 1 million token context capable of ingesting lengthy meetings. Notice the pricing at the bottom. V4 Flash costs just 14 cents per million input tokens, making continuous audio analysis economically viable. A massive, low-cost memory engine is the absolute prerequisite for an AI that can sit through and remember endless corporate meetings without bankrupting the user. This chart reveals a broader trend across the industry. Digital workspace apps from calendars and task managers to docs and file storage are increasingly positioned as controllable surfaces orbiting around a central AI orchestrator. When a system requires live audio feeds, file manipulation privileges, and calendar controls to function, the organization's attack surface physically expands. Look at the right side of this layer map. Researchers found malware and OpenClaw skills designed to steal credentials and crypto keys. On the left, an AI program to record sensitive business discussions creates immediate legal liabilities. There is also an operational vulnerability. Because these systems rely heavily on third-party API providers, companies can face sudden outages if a vendor alters its usage rules or throttles access, directly restricting the agent's uptime without warning. This timeline charts the trajectory from basic chat interfaces toward autonomous participation in meetings and follow-up work. Whether these agent workspaces succeed depends on if their productivity gains can outweigh the significant security and governance risks.